YouTube. This is Alternate, and this is my first video. In this channel, what I'll aim to do is be able to introduce people to programming through easy-to-understand ways, such as Python and Scratch. So today, I'm going to be doing a beginner project in which I show you how to create an algorithm that will generate prime numbers, and we'll even take it a step further to create one that generates consecutive prime numbers. Alright, so to begin, let's look at what we'll be doing and exactly how the code will work. Here, there are all the prime numbers from 1 to 100. They're highlighted. So all the numbers from 1 to 100 with the prime numbers highlighted. And as you can see, there's not really a pattern between these prime numbers. I mean, they're all odd, but other than that, they're hard to predict. So what I aim to do is I'm going to look at any random number. For instance, 55. Then I will look at every number underneath it until I reach 1 and divide that number, or divide 55 by that number. So for instance, for 55, I'll divide 55 by 54, and then 53, and then 52. The reason I'm doing this is I'll check the result and see if it's an integer. If that number is an integer, that means that 55 has factors such as 11. 55 divided by 11 is 5, and therefore 55 has one factor, 11. So if any of the numbers that we get as a result of these divisions are integers, that means that that number is not that number is prime. For instance, 7 cannot be divided by any of these numbers to get an integer, therefore 7 is prime. So let's begin with the code. One thing before we start, I'd like to recommend two resources to you in your journey to learn Python. Firstly, Visual Studio Code. That's what I'm using as my editor. I've really found it helpful in coding, and I am the other resource is W3 Schools, which has it's basically a library with a multitude of programming languages, and it will guide you through as you go. So with that, let's begin. To begin, let's create two values. One is for composite numbers and the other is for prime. Now, I chose 0 and 1, and the reason why will be apparent later in the code. But you can also write true for prime and false for composite. It doesn't really matter. They're interchangeable, but I'm using 0 and 1. We won't actually be using the ones and zeros, we'll only be using the words, so it doesn't matter too much. Now firstly, as I said earlier, our first goal will be to check whether any given number is composite or prime. So let me start by creating a function. I'll call it check prime number. And I'll take one input, which will be num, which will be any number, so the number that we're trying to check, and let's create that function. So we're going to need to reiterate. As I said earlier, we're going to need to check multiple numbers to see whether we can divide that number by a starting number to get an integer. So we're going to use, instead of a for loop, or we're going to use a while loop for this, and we'll use x to help us through that. We'll see why later, but for now let's just create these variables. Okay, so we're going to, all of these will be needed to check whether each number is prime or composite, and well, I'll explain after I write this while loop. All right, so what I just did is, firstly, I'll put everything in here in a while loop. So while the statement is true, this will be, while this statement is true, this will keep going on over and over and over until the statement is false. So we're starting with the number, or whatever number we use, we can assume it's prime until we prove it's composite. So that's just the way we're doing this. That's why here we made the status of the number prime. This global status is just allowing us to use that outside of this function. So we're assuming the number we're starting with is prime. And while the number is greater than, while x is less than the number, and the status equals prime, we're going to do this. So and then after we do this, if it's true, we're going to add 1 to x. Basically, that's the way we can say we're going to do this until we reach this number. So if this number is 5, we're going to do this 5 times, because we'll keep adding on to x until it's this. So that we only need, for instance, if we have the number 5, we only need to add 1, 2, 3, 4, 4. Sorry, we only need to divide by those numbers. So, and the reason I didn't start with 1 was because we won't need to divide any number by 1. We already know what that will give us, and we know that that will not prove the number to be composite. So, I also did, I only had this keep happening if the number was prime, because once it's composite, we already know it's composite, and we no longer need to check whether that number is prime. So what I did here is I used an if statement to check whether the number is prime or composite. So I divided the number by x, and then used this to check whether that number is an integer. And if this is true, if that number divided by x is an integer, that means that it's composite. It's no longer prime. We just proved that this number is composite. And that's the other reason why we're using x here, because we want to be able to check each number and only the amount of numbers that we need to. So now if this is for if the number is composite, if it goes through this if statement and it still comes out composite, none of these are integers over here, then that means that number is prime. So we can create another if statement outside of the while loop, because the while loop is only to prove a composite. And this other if statement will be if status is prime, we can return int number, because we don't want a fraction for this. This is for whole numbers. And else, this would mean that the number is composite. We would return not prime. So the reason that I am not printing this is, it could be printed, but when we want to check prime numbers, printing it won't actually help. So I'll return it instead. And we can actually check this by just saying print check prime num, and we can check any number. So let's do some ones we know are prime. For instance, 5. And we get the number 5 returned because this is prime number, and we asked it to return that number if it's prime. But if we do 6, a composite number, it will return not prime, because 6 is not prime, and we asked it to return not prime. So now with that, we can start creating our algorithm to check for consecutive primes. Before we start creating this algorithm to find consecutive primes, I thought I'd briefly explain what consecutive primes are. Consecutive primes are any two prime numbers with a spacing of 2, or one number in between them. That number will be even because, of course, even numbers cannot be prime numbers with the exception of 2. For instance, 3 and 5, they're prime numbers as close as they can get, or 5 and 7. As you can see, similarly to all the other prime numbers or consecutive prime numbers are rather randomly scattered. I guess most of them are 7 and 9 or 1 and 3, but they are still quite randomly scattered around. So the way we're going to do this, I thought it would be helpful if I drew it out for you so that my code could be more easily explained. Now let's take any number. And we're basically going to add all of the prime numbers less than this number into a list of primes. This number can be as great as you like. You'll just get more numbers the greater this number is. So for instance, if we took the number, let's say 10, well, 10 isn't a prime number, so it wouldn't be added to the list. But we'll look at all the numbers lesser than 10. 9, 8, 7, 6, 5, 4, 3, 2, and 1. And we'll get rid of all of the non-prime numbers, and we will not add those to the list. So all of these, I guess 1 is not prime. And we're going to add that to a list of our prime numbers less than 10, of course greater than 0, so that would be 7, 5, 3, and 2. Now we're going to look at these prime numbers. For each one of these, we're going to compare it to the number next to it and find the difference. So 7 and 5, 5 and 3, and 3 and 2. And what we're going to look at is whether or not this difference is 2. If this difference is 2, 7 and 5 will be consecutive primes. 5 and 3 will be consecutive primes. 3 and 2 will not be because the difference is not 2, it's 1. So we'll basically print out all of the pairs of consecutive primes. And of course, we can get numbers a lot bigger than 10. And we'll actually be trying that out later. So let's start on with the code. Alright, so on to the code. To keep our code organized, let's create a function for this. Find consecutive primes. Let's take one argument, that will be b, and no specific reason for b. I just love using letters, as you can see above. So let's create the list I talked about earlier, prime numbers. And we can leave it empty right now because we don't have any prime numbers to store. So once we do, we'll add them to it. And let's add y. So what we're going to try and do with y is y will be the numbers that are underneath whatever number we're talking about. So before the example was 10, 10 will be b. We'll add that we want to use 10 to the function here, and we'll use y to represent all of the numbers below 10. So we'll use a while loop like we did above. We're saying while y is less than b, because once y is greater than b, we can just end there. We checked all the numbers below b, and well, for y, we can check prime none, to check whether y is prime. I'm going to add a y equals y plus 1, or just plus equals 1. You can also do that, as I did above, for a shorter form. Of course, this will be at the end of our code. Well, we have a few more things to put in, but just as a reminder that this will keep increasing y until it's at b. So, if the status equals prime, that's what we're looking for. We want to add prime numbers to our list of prime numbers. We'll add or append we'll add y. Oh, I misspelled this. Prime numbers. We'll add y to prime numbers, and of course it will return a value which is an integer. So we can just put that in here. We already know it's prime, so it won't be returning texts over here. It will be returning this number. And the reason we had to do this is we need to get a status for this if statement. This if statement will not run unless we already have status. So we have to run it and then run it again for that reason. So inside this if statement, we actually have to write another if statement, and I'll explain why in a bit. First, I'll write it out and you guys can just copy it. All right, so this if statement basically checks whether the last number in the list minus the second to last number in the list is 2. So if these are consecutive primes, let's say we're checking this for 6, the last prime number in the list would be 5, and the second to last would be 3. So since 5 minus 3 is 2, these would be consecutive primes. And we only need to check this if we just added a prime number, because if we didn't, well, it does not, of course, it can't be a consecutive prime if it's not a prime number. So we can actually, we'll just print this because we don't need to add it anywhere else. So we can print prime numbers, the length of this, prime. So this is the same thing as up here. It's still the last number in the list. And we can say let's add spaces to make it a bit clearer. And I'm just using strings to make it a bit clearer. You can really put whatever message you want, but the point is you have to make sure you're saying these are consecutive primes. And our error, we didn't add. What did we not add? Okay, so I didn't add commas. I'll do that quickly. Perfection. So I guess we can close the space a bit. We don't need that much. And as I said earlier, this will just help reiterate or make it reiterate until y is equal to a certain value. So to recap, what we just did is we're going to take any argument. We can say any number. So let's use 100. And we will create a list for all the prime numbers less than 100. That's done here. We check whether the number is prime. If it's prime, we're going to add that number to the list. And we do this until, and then we'll add 1 to y. So we'll do this until y is equal to b. So we'll check 1, and then 2, because we'll add 1, and then 3, because we add another 1, 4, 5, 6, all the way up to 100. And if we just added a prime number, well, then we'll check whether the number next to it is also prime over here. And if they are, we're going to print that. So if we try to find consecutive primes for all the numbers up to 100, let's see what result we get. We get 5 and 3, 7 and 5, 19 and 11, or 13 and 11, 19 and 17, all of these. And well, we can check this over here. And well, if you look through, you'll see that all of them are consecutive primes, which is great. And the cool thing I love about these algorithms is we can try really high numbers and find really interesting things. For instance, I'm going to do 10,000. Let's make it interesting, actually. 50,000. And it will just keep going until it gives you all of the consecutive prime numbers up to 5,000. Of course, if we had really powerful computers, we could do as much as we wanted. But this will allow you to do whatever number you put in there, and I guess all the numbers below. Thanks for watching. If you enjoyed this video and would like to see more content like this in the future, please make sure to leave a like and subscribe. See you next time.